f is a function defined from r square to r square be given by the formula x f of xy equal to this expression, then f is discontinuous at 0 0. F is continuous at 0 0 means if option a or b is true, then other one will be false. F is differentiable at 0 0. F is differentiable at 0 0, and the derivative of f at 0 0 is invertible. So basically, differentiability and continuity is in this problem. If function is differentiable, then we can easily tell about the continuity of the function. So, and differentiability we can easily and fastly check by directional derivative. So we are going to check this problem by directional derivative. As function structure is given by this expression, and you can see mod or absolute function is involved in this. Whenever absolute function is involved, then break for positive value and negative value. If you are going to break this one, if x and y both are greater than 0, then there is no change in this structure. So f of xy will be 3x plus 2y plus y square plus xy, or you can take absolute value 2x plus 3y plus x square plus xy. If one of them is less than 0, is x or y is less than 0. If both less than 0 means negative, then absolute negative turns to positive. So absolute value will again positive value, give positive value. So if one of them is negative, then this one can be written as 3x plus 2y plus y square plus minus of xy, because only one is negative, so take minus one time 2x plus 3y plus x square plus minus of xy. This is the value of the image. So you can check directional derivative for positive xy or negative xy, but this may be sometimes lengthy. So we need to check this by one step. What is directional derivative in the direction u of f at the point 0 0? This one will give you differentiability of the function at the point 0 0, and also continuity. Remember one point, if if directional derivative duf exists at a point a, then this doesn't imply that function is continuous at a. All directional derivative everywhere is existing, but function is not continuous at that point a. Now we need to investigate further, but if function is not differentiable, then function is not continuous. We have direct results. As function image of the function involve xy means two variable, f of xy means function of xy. So consider this one as f1 and this one by f2. So f is a function of f1 f2, and f1 and f2 are function of xy. So apply chain rule here. Chain rule. What is chain rule? Now represent directional derivative or gradient df of xy can be represented by partial f1 with respect to x, because f is a function of x and f1 is a function of y. Similarly, f2 is a function of x and f2 is a function of y. This is a matrix representation or partial derivative representation. Simply I write matrix representation or transformation. From the above function, because absolute value of xy is involved in this one, so whenever it is, this part is very easy to take partial derivative either with respect to x or y, but this one, if one of them is negative, then there is no change. What you should do, if one of them is negative, absolute value or absolute function will give the value negative of this function xy. Now take negative inside and take variable outside as if we are treating as a constant, or you can understand this one as this value is minus of xy. Suppose either x is negative or y is negative, so mod will give this value. If you are going to take derivative with respect to x, then take x outside, so its derivative is 1 and mod same as, means put negative of this one, negative of y, and put mod value. So there is no need to write minus there. So minus uh, can be easily managed by this mod function. So value of this one will be 3 plus mod y, 2 plus 2y plus mod x, 2 plus 2x plus y, and this is 3 plus mod x. This is the matrix representation. And whenever you find directional derivative, this one, because this is partial derivatives, so this one need to take dot product with the vector in which direction we are going to find. Suppose this is vector u, so take as a column vector and multiply this one. So whatever the value of u, this df of xy is existing for all value of xy, means all xy that are coming from r square, this is always existing, means limiting value is existing, means function is differentiable everywhere. Also directional derivative is existing at the point 0 0, because question is about directional derivative at 0 0, and differentiability is also at 0 0. So in first option, f is discontinuous at 0 0, this option goes wrong. F is continuous at 0 0 but not differentiable, function is continuous and differentiable both, but by this word not, this is again a wrong option. F is differentiable at 0 0, this one is true, f is differentiable at 0 0 and the derivative df 0 0 is invertible. Now we need to check invertible. As this matrix representation we have, and we need to check invertibility, or at 0 0 means put the value 0 0 in this. So this one will be 3 2 2 3. This we will obtain matrix this one, and we need to check determinant of this one. Determinant of df at 0 0 is 3 3 is 9 minus 4, 9 minus 4 is 5, which is not equal to 0, so invertible. So invertible, sometimes we refer this as a Jacobian. So option C and D both are right.